All right, homework 2, question 4. And we start out where we have Lake Michigan, and there's a 50-knot wind going over a fetch area of 80 nautical miles for a 10-hour length of time. So our time length here is 10 hours. So we're given this wind velocity of 50 knots, a time of 10 hours, and an overall length here of 80 nautical miles. And our first question that we're asked here is, what is the significant wave height and what is the period?
Okay, we're going to start with this SMB chart here. And this is going to be all we need to be able to get these numbers. First thing, we're going to take our wind speed in knots, which is, there's no conversion change because it's given to us in knots. And I've already circled the 50 here to say that's our 50 knot line. And I'm going to go ahead and I'm going to draw a blue line right across that, just to kind of make it clear. I'm not going to go all the way across because I don't need to. And then I'm going to start with a period being 10 hours, which you can see right here, 10 hours. So I'll circle that to make it clear, 10-hour period. And we're going to go up along this 10-hour line right here, all the way up to that 50 knot mark. And right here, if we look at our wave height line, which are these right here, we get about between 25 and 20, so I'd say about 22.5 feet. And our period between 11 and 10 seconds, so we'll say somewhere around 10.5 seconds. Now, that is if we use the if we use the time, the duration. If we go by the fetch length, which we know is 80, as I have circled here, so this is 80, and it's in nautical miles, which is good because we don't have to do any conversions either. Then I can go straight up. If we go over here and look at our fetch length, that's basically the line that we can go straight up with. So we're going to take this 80, right, and we're going to go straight up right here. So just to kind of reiterate that, there's the 80 line. We're going to go straight up. And now, if we look, our fetch length is somewhere between, what, 9 and 10 seconds. So we're going to put today a 9.5 second period. And it's between, let's see, just a little under 20 feet. Let's see, that says 18 feet there. So I'd say about 19.5 feet.
Okay, so here are our numbers, and you can see that based on our fetch distance of 80 kilometers, or excuse me, 80 nautical miles, and our duration of 10 hours, we're not going to be able to go above 19.5 feet for our significant wave height, or a 9.5 second period. All right, so this gives us a duration limited calculation.
And what that means is that the wind only has to blow for a certain amount of time before it's no longer becomes a limiting factor. So basically, the wind here has blown for 10 hours, and so at 10 hours, even at less than 10 hours, that's plenty of time for us to make what we would call full seas. So the question then becomes, well, what is the minimum time for this to be fetch limited? Well, if we now look at this time where we're at right here with our duration limited time period of 50 knots, if we were to actually push this thing down to how many hours, we're somewhere between 6 and 8 hours here. And so this would probably be around 7.5 hours for a fetch limited condition. So that is, if the fetch was only blowing for 7.5 hours, that would be our limiting factor of our wave heights.
Okay, so we all know that what we're trying to find now with this last question is that, assuming we have a deep lake and the conditions before, how long is this going to propagate across Lake Michigan toward the other side of the lake? So we know that distance equals speed times time. So if we kind of manipulate this, so we're looking for the time now. So now we just move that over. Time is going to be distance divided by our velocity. And our velocity in this case is our group speed. But our group speed is actually going to be, since this is a deep water condition, it's going to be our C naught over 2. So we have to find, first off, if we're going to find our velocity here, we need to find C naught. So C naught for a deep water condition is going to be equal to gravity times the time, or period rather, divided by 2 pi. And our gravity we know is 9.8 meters per second. We know that our period is around 9.5 seconds, right? Which knocks that out a little bit. And we're going to, and we have 2 pi here. Right, so this winds up becoming something like, I think it's 93.1 divided by 2 pi, which in turn comes into, what is it, 14.82. So now if we take C naught equals 14.82, that means 1/2 C naught, or C naught divided by 2, equals 14.82 divided by 2, which equals somewhere around 7.41. And this is speed, so this winds up becoming meters per second. Now for distance, I got some help from Google. 80 nautical miles equals, what is it, 148,160 meters? Okay, so as we said before, our time, our period, or time here is going to be our distance divided by the velocity. And we know, so from our distance now, we said from Google's 148,160 meters. And our velocity here, actually our C naught, 7.41 meters per second, 0.41 meters per second. Knock those off. And this comes to about 19995 seconds. Or if we want to put that in kind of more normalistic terms, we divide this by 3600 and we get probably about 5.55 hours.